into calculus, when you talk about the slope of a curve, you take the derivative. And that's what some of this is working with. You're dealing with the exponential there, so it doesn't have a constant slope. It's not the same between 2 points. I know it's decaying, 1, because that says a half, 2, because if I plot these 2 points, okay, if it bothered you that I plotted the right point first, you plot the point 0, 3 right there, and you plot the point -1, 6. So I plot that point. Because it's in this format right here, that says that your graph's going to be an exponential, which is either going to curve like this, or it's going to curve like that. It's either going to be growth, which is here, or it's going to be decay, which is right here. So as I look at it, where those 2 points are tells me it's going to be decay, which says that if I had a whole number right there, or a number greater than 1, then I solved wrong. Because that value, because it's decay, when you connect those 2 points, it says that value of B has to be between 0 and 1. From what you were doing with your activities at the back end that day. See, you have some puzzled. What if I gave you 2 other points? You work through this problem for me. What if I gave you the points 0, -18, and the point -2, -2? Okay, I want to know what is an exponential function that's going to go through those 2 points. Exponential function is going to be in the format of y equals a b to the x. What is this value right here? It is your y-intercept, which is found right there. So I know my equation is going to look like y equals -18b to the x power. I need to figure out what b is. If I think about what b should be, let's visually just kind of get an idea of where these points are at. Oh, first of all, well, we can plot those points. You get 0, -18, which is clear down here, right? And then I have the point -2, -2, which is somewhere right there. So what's your graph going to do? How's it going to curve? How's it going to curve? How can I connect this point right here and this point right here? There you go. Jackson's got it. It's going to do something that looks like that right there. It's going to curve downward like this. How do I know instead of exponential growth or exponential decay? Why am I all of a sudden getting it flipped over the x-axis? Negative what? What's negative? That y-intercept is negative. And when that a value is negative, it flipped it down. It flipped it over the x-axis. If you look at the graphs that you had to graph on that paper early on when I had you working in groups, and we were looking at what happens with those graphs, we talked about that -2 to the 1/2 power. We did some over there. When this a value was negative, it caused that. Or this. So let's come back over here. And let's figure out what the graph is going to be, or what the b value is going to be. So what is the y value of the point? -2, -18. What is the x value? -2. What's the first thing you need to do? Divide by -18, and -2 divided by -18 is 1/9. That's equal to b to the -2. It's a negative exponent, so what do we have to do? Flip it. So if I flip it, well, okay, or you could do this, 1/9 is equal to 1/b squared. I just wrote b with a positive exponent. How do you solve from there? Cross multiply. So b squared times 1 is b squared. 1 times 9 is 9. And then what do? Not cube root, square root. So now you need to take the square root of both sides. So b is equal to 3. So I get the equation y equals negative 18 times 3 to the x power. Take your graphing calculator. I'll just say right now, sorry Macy or whoever watches this, that I have my Elmo plugged in for the first part. Okay, so the question is this growth or decay? I will tell you this much, because that's going to make a difference. Knowing whether it's growth or decay is going to make a difference on knowing what that value is and whether that value is correct, right? So what you want to do is I think you should have an idea by just looking at the 2 points that they give you that it curves down like this, right? What happens? It's flipped down there because of that negative coefficient right there. If I were to flip it up, what would your graph do? It would go like that. Would you agree if I were just to flip it up? That would be if that's a positive 18 instead of a negative 18. Is that growth or decay? That's growth. So if that is growth, what should this value, that b value, be? More than 1. And is it? Yes. So that's the way you'll want to check it, right? Because if it were to do this right here, if my graph did this, can you give me, I don't know, that's just a rough graph. Can you give me an idea of what your equation might look like? Just pick values. There's certain things that have to be correct, though. What do you know about A? It has to be negative. A has to be negative because it's flipped down here. I don't care. Give me a number. Negative what?
9.
Negative 9. I don't care. That sounds like a good one. Now, what do you know about the B value? B. If I look at that, if I were to flip that back up, what's it going to do? It's going to go like this, right? An improper fraction would be positive 5/2. That's greater than 1. So that's decay, which says, what about this B value right there? It's got to be positive. B is always positive. It's got to be this base value. I don't want X. Your base value has to be greater than 0 and less than 1. So give me 1. 1/2 to the X. Okay, type that in on your graphing calculator. Y equals negative 9 times 1/2 to the X power. And tell me if your graph takes this shape right here. I want that shape. This is just an example of what it could be. I'm not saying that's what it is because I didn't give you points over there. But it should take that shape right there. It's an exponential decay that has been flipped over the x-axis because of that y-intercept. Does your graph do that when you type this equation in right there? Yeah. Making a connection between the equation and the graphs. And you may ask, what does all of this mean? Well, it's not any different than if I tell you this right here. What's that the graph of? It's a line. It's just a straight line with 2 pieces of information. What are they? The slope. The slope is 1/2, and that's the y-intercept. So your slope is right here. That's going to tell you how far up and over you go between 2 points. You know if it's a positive slope, it goes this direction. If it's a negative slope, it goes in that direction. You know that that is the y-intercept. The 2 is the y-intercept. So when we look at an exponential equation, we know my graph's probably going to be growth. Depending on what B is, it's going to be decay. Depending on what B is. And this A value right here is going to tell you the y-intercept, not any different than that +2 in the example we just looked at. And if that's negative, what do you know about your graph? If the y-intercept is negative, what do you know about your graph? It's going to go like that or like that, right? And if it's positive, then it'll be one of these 2. This is a positive A value, and these 2 right here or a negative a value. And then you can take the negative 1, flip it up to determine whether this should be between 0 and 1 or greater than 1. Starting to see a connection between everything. What was it? Yeah. Okay. I'll be here. All right, this right here. Yesterday, or even the bell ringer today, you worked through this problem, but it would have been written this way. 4 to the 3p minus 1 is equal to 1 over 256. Let's solve it as if it were in equals. Can you do that for me? Can you solve this in red? You're guessing what? It can be, well, we'll see. That's a good assumption. I see what you're saying there. Big word. Okay, so what do I want to do? 256. 4 to what power? What, did you figure out 2 to what power?
It's not 16.
It's not 16. 4 times 4 is what? 4 times 4 is 16. 16 squared is 256. And 16 squared, here's 2 fourths to give you 16, and here's 2. Let's try 4 to the 4th. Take your calculator and say 4 to the 4th. What's 4 to the 4th? 256. It's 1 over 256, though. So that means 1 over 256 is 4 to what power? Negative 4th power. Now, if I couldn't get 4 raised to that power to equal 256, then I would have to change both bases to what? 2. So this is 4 to the 3p minus 1 power. What does that tell you? It tells you that if the bases are the same, the exponents have to be equal. How do you solve? Add 1. So you get 3p is equal to negative 3, and then what? Divide by 3. So p equals negative 1. Okay, I'm going to put that in over here. If I put negative 1 in, I get 4 to the negative 4th, and that should equal, when you type that in on your calculator, you should get 1 over 256. Now, if you don't, because you have a graphing calculator, type in 4, use your caret key, raise it to the negative 4th power, and hit enter. Does it give you a decimal? Now there is a way you can change that to a fraction. To change it to a fraction, you want to go to, not mode, go to, hit the math key. Hit the math key, which is under the alpha key. And the first thing it says fraction. So hit equals, and it'll, oh, why do I have it right there? I have it in the wrong spot. Okay, so you have your decimal value up, correct? Now hit math. Fraction, and it'll say math with an arrow fraction. Hit enter again, and it'll give it to you as a fraction. Oh, because you have one that looks like Landon's? I have to have it as an answer as a decimal. Did everybody see how to change that decimal to a fraction? So you can see if it's equivalent, I hope. All right, the thing is, those are equal to each other. Here's the thing, if you solve an inequality, you solve an inequality just like you do if there's an equal sign there, unless you multiply or divide both sides by a negative number. If you multiply or divide by a negative number, you have to flip the sign. You got to flip the sign. But in this case, we didn't multiply or divide by a negative number. If you just want to look at it as a negative, as an equal sign, we got this value of negative 1, which does not work, which is what Trista pointed out, because it doesn't say equal to. So she says it's not going to work. Pick a value that's greater than -1. 0. Greater than. Greater than. 0. If I put 0 in, if I put 0 in for P, I get 3 times 0, which is 0 minus 1. That's -1. What's 4 to the -1 power? 1/4. Is 1/4 greater than 1 over 256? Yeah. No, it could equal 2. If it's 2, I get 3 times 2 is 6 minus 1, which is 5. Is 4 to the 5th greater than 4 to the -4th? 4 to the 5th. Is 4 to the 5th greater than 4 to the -4th? Yes, it is. So that works. If I picked a value less than -1, such as Eric's -2, then I would have 4. If I put -2 in for P, you get -6 minus 1, which is -7. Is that greater than 4 to the -4th? No, because you're talking about a fraction, and the larger the denominator of the fraction, the smaller the number. 1/8 is smaller than a half. You'd rather have half of the pizza instead of an eighth of the pizza. Okay, so solve this one. Now it could be greater than or equal to. I would just start taking 3 on my calculator because you want to get them in the same base, and just raise 3 to the 5th, for an example. I know 3 to the 4th is 81, so try 3 to the 5th. Just pick an exponent and try it. What is 3 to the 5th? 243. So if it's 1 over 243, because that, you get this, it's 1 over 3 to the 5th. So if I'm going to move it up, I get 3 to the -5th is greater than or equal to 3 to the 2x minus 1. You could set it up as an inequality if you want, or we could just say the exponents are now going to be equal. So I'm going to move the 1 over. I'm going to divide by 2. I get -2. If I put -2 in, I get -4 minus 1, which is -5. That's equal, so that works. So I know it can be equal to -2. If I look at it on the number line, if it's equal to, that means you're going to get this closed circle because it includes it. On the last example, we left it as an open circle because it didn't include it. But pick a value on what side. 0 is always the nice one to pick because it's an easy number to calculate. 0 ends up over here, right? So if I put 0 in there, I get 3 to the -1st is greater than or equal to 3 to the -5th. That means is 1/3 greater than or equal to 1 over 3 to the 5th? Is that true? But it's greater than. It has to meet one of the conditions. Equal to is because I put that close sign there. Any value you pick over here is going to make it true. Pick 5. That gives you 3 to the 9th. Is 3 to the 9th greater than or equal to 3 to the -5th? Oh, yeah, for sure. So it's got to be this way. So your answer would be that x has got to be greater than or equal to -2. Because I let x be 0. 0 times 2 is 0 minus 1 is -1. You have an assignment that is due on Monday. Listen closely because there's lots of problems here. Unless you want to do the whole thing, I think that was just what you need to do. 1 through 17. 1 through 17. That's the assignment. So 1, 2, and 3, you just have to match. Does one go with graph A, B, or C? Number 2, is that graph A, B, or C? And number 3, is that graph A, B, and C? And I would hope that A would be the answer for all 3. 4 and 5, you need to make a sketch of it. And then number 6, you need to just tell me, is it growth or decay? Which we talked about, that depends on which value?
The
B. It depends on the B value. And then 8 and 9, ooh, those look pretty darn familiar. Yeah, I have just done those. 10 and 11 are like some examples that we talked about yesterday. 12 are like ones that, and 13, 14, 15, the rest are, those last 6 are ones that we've been working on before. Yeah.
So you're just going to find like on that 12, because you just need to find the X.
You need to figure out whatever the variable is in that extra that's going to make it short.
This is kind of a dumb question, but for this one, can you still do equal 70%?
You can, but then as the final step, your answer is if X equals this, it's going to be X is greater than that number or less than. What you find when you put it as an equal, you put it as an equal to that critical point, and then you got to pick values on each side that you determine. Is it the values that are less than or the values that are greater? I know that when you divide by the other numbers, I'm one that is a lot more by putting sorry, I just know. What's the assignment? What's the assignment? Don't do something, do it Monday. I am here after school. Check, I might still be here after basketball practice. Text me if you have a question. Look. Stuff might be posted in Schoology. I told you 2 of these we did in class today. They might be posted in Schoology. Some notes are posted there already. And I'm recording all this right now. But you might also find out that